The objectives of learning this module are to understand the basic characteristics of glaciers, formation and types of glaciers, distribution of glaciers, geological action of glaciers, ice ages and its significance, glacier and global climate, importance of glaciers. Introduction. Glaciers are the rivers of ice. Glaciers are among the most beautiful natural wonders on earth. Ice fields are very good and excellent recreational resources. Most of these ice-covered areas are existing in the high altitude and high latitude regions of the world, including the polar regions. The word glacier is derived from two roots. One is from the French word glace, meaning cold place, and the other one is from the Latin word glaciae, meaning ice. Glaciers are very dynamic systems on the planet Earth. Studying the formation, distribution, and effects of glaciers is an interesting topic while understanding of the Earth and atmospheric sciences. In this module, glacial systems and their characteristics, their formation, distribution, movement, their role as geomorphic agents, ice ages in the history of the Earth, benefits of glaciers and hazards of glaciers are discussed. Glacier belongs to the sphere of ice and snow. Cryosphere. The word cryosphere comes from the Greek word for cold, cryos, denoting snow, river and lake ice, sea ice, glaciers, ice caps, ice shelves, ice sheets, and frozen grounds. It is the sphere of the Earth's layer of snow and ice. Glaciers are important components of the global cryosphere. Glaciers are important components of the global cryosphere. A lot of studies have been made on the global distribution of glaciers. People around the world rely on the snow and ice to continue their way of life. The cryosphere is central to many fauna and flora which thrive on these areas. Glaciology, the science of glaciers. Glaciology is the scientific study of glaciers. It is scarcely a century old. It deals with the study of origin, occurrence, distribution, movement, and the geomorphic activities of glaciers. A large number of glaciologists and other scientists have contributed to this subject from Greenland, Alaska, Canada, Baffin Island, Norway, Sweden, Switzerland, India, China, Britain, and the USA. The World Glacier Inventory, WGI, found that there are more than 100,000 glaciers distributed all over the world. Parameters like their geographic location, area, length, orientation, elevation, classification of the morphological type, and moraines are included within the inventory databases. Glaciology, a growing branch. Glaciology also aims to investigate the following aspects: differential movements within glaciers, both in time and space; structures in glaciers, planar structures and crystal fabrics; phase relations in glacial ice; oxygen isotope studies; micrometeorology and the regime of glaciers; remote sensing and climatic monitoring; glacial mass balance computations; global climatic modeling and impacts on glaciers. Glaciers and glacial systems. Glaciers are the extensive, solidified natural water masses accumulated as snow and ice. They are made up of fallen and accumulated snow which have gradually compressed into a large and thick ice mass. This process might have happened and repeated over several hundred years. Glaciers are long-standing masses of ice having the ability to move slowly. Due to sheer mass, glaciers flow like very slow rivers. Glaciers are not uniform in their origin, structure, and distribution. Specific densities of glacial masses. There is a progressive increase in density of various forms of snow and ice masses. The following are the specific densities of these masses. Fresh snow has a density of 50 to 200 kg per meter cubed. Firn has a density of 400 to 800 kg per meter cubed. Glacial ice has a density of 830 to 910 kg per meter cubed. Pure ice has a density of 917 kg per meter cubed. Water has a density of 1000 kg per meter cubed. Firn is a term derived from the German, meaning dense old snow, in which the crystals are partly joined together, but in which the air pockets still communicate with each other. It has a sugary texture. Firn is a multi-year snow that is in transition from meteoric snowfall to a glacial ice. Typical firn densities are 550 to 900 kg per meter cubed. Historically evolved ice fields. Similar to rock formation, glacial formation dates back to several million years. The only difference here is that the Earth had extensive formation of glaciers, which later got melted and reformed in a cyclic manner. These happened during specific periods of the Earth's history called ice ages. Due to that reason, glaciers can be thought as remnants from the past ice generations. Periods of glaciations are considered to be rare events in the history of the Earth. Ice fields and glaciers are very interesting and ever-growing subject areas of study, research, recreation, and enjoyment. Glaciers are distributed over mountainous regions and polar continental regions. Parts of glaciers. Horizontal zonation. A glacial system is an open system of ice that flows under the pull of gravity. The mountainous glaciated regions include the following zones from highest altitude to their foothills. The zone of accumulation, where the snowflakes form crystals of snow and join together. The zones of crevices and internal flows. The zone of ablation, melting and evaporation. The zone of terminal sediments containing glacial moraines. Glacial outwash plains and braided flows. The zone of permafrost on plains. They are all stable up to some elevation level, wherein there is no melting or evaporation. This imaginary line is called as the snow line. Below this line, the masses of ice flow outward slowly under the influence of pressure of their own weight and mass. They move down the slopes due to brittleness and internal flow mechanisms. A lot of crevices are formed perpendicular to the direction of flow in this region. In the zone of ablation, both melting and evaporation starts acting on the ice. Due to the erosive action of glaciers, sediments are pushed along the flow path of glaciers as moraines. Along the foothills, the glacial outwash plains and braided flows are common features to see. These are beautiful regions with flow of water and deposition of sediments along the courses. Vertical zonation of glacial mass. Vertically, a glacier is divided into three zones as rigid surface zone, zone of plastic flow, zone of bedrock with rock fragments frozen into glaciers. A glacier originates at a location called its glacier head and terminates at its glacier foot or terminus. Snow line. Glaciers always exist above the snow line. The climatic conditions responsible are high snowfall in winter and cool temperatures in summer. This climatic condition allows more snow to accumulate as glacier in the winter than summer months. These will melt in the summer depending upon the physical conditions. This is why most of the glaciers are found either in high altitude mountainous regions or around the polar regions. Snow line is the point above which snow and ice cover the land throughout the year. This level is controlled by several factors. The two important ones are the altitude and latitude. For example, in the Himalayas, the permanent snow line can be as high as 5,700 meters. Beyond the tropics, the snow line becomes progressively lower as the latitude increases to just below 3,000 meters. The Alps is an example for this situation. The snow line falls towards the sea level at the ice caps near the poles. The snow line occurs at different altitudes in different places. Examples are, in Washington state, the snow line is around 1,600 meters. In Africa, it is over 5,100 meters. And in Antarctica, it is at sea level. Characteristics of glaciers. Glaciers have certain basic characteristics. They are: glaciers are made of ice. Ice masses have unique structures and density. Glaciers are originally formed on land and extended into the water bodies. Ice crystals are the fundamental component of glaciers. In addition, glaciers consist of air, water, and rock debris. Ice crystals are also weak. They can be made to sheets parallel to the basal plane. This is the basic reason that makes glaciers to deform quickly, and due to their own weight, they tend to flow. Another unique characteristic is that water is less dense in its solid form than in its liquid form. Due to this, the glacial ice tends to float or stay above some watery bodies. All glaciers must originally form on land, and subsequently they might have reached the seas. Glaciers vary in their dimensions. The largest glacier in the European Alps descends for 23 kilometers from peaks of over 4,000 meters and supplies meltwater for a major electrical power station owned by the Swiss railway system. The smallest glaciers are only a few hundred meters across, such as this tiny Circ Glacier, Teton Glacier in Grand Tetons National Park, Wyoming, USA. Glaciers require very specific climatic conditions. Most of the glaciers are found in regions of high snowfall in winter and cool temperatures in summer. These conditions ensure that the snow that accumulates in the winter isn't lost due to melting or by evaporation or by calving during the summer. Such a type of condition prevails only in polar regions and also in the high altitude mountainous areas. There is a major difference between a glacier and a sea ice. Sea ice is simply frozen ocean water. It forms, grows, and melts in the ocean. In contrast, icebergs, glaciers, ice sheets, and ice shelves all originate on land. Sea ice occurs in both the Arctic and Antarctic. Classification of glaciers. Glaciers are classified into various types based on morphology, temperature, and activity or activeness. The morphological classification brings out the types of glaciers as niche, cirque, alpine, outlet, transaction, Piedmont, floating, ice cap, ice sheet. The temperature-based classification shows the following types of glaciers: warm temperate ice, cold polar ice, intermediate subpolar ice. The activity-based classification shows the following types of glaciers: active and passive, undernourished, dead, equilibrium. Universally, glaciers are classified based on their stage of development, form, and relationship with the supply and waste areas. This classification shows the following three major types of glaciers: mountain or valley glaciers, continental glaciers which include ice sheets, ice shelves, and ice fields, intermediate glaciers, Scandinavian, which include plateau glaciers and Piedmont glaciers. Glaciers are either unconstrained by topography or the topography actually constrains the glacier. Mountain or valley glaciers. The mountain glaciers are relatively small glaciers. On the planet Earth, the largest mountain glaciers are found in Arctic Canada, Alaska, the Andes in South America, the Himalayas in Asia, and on the Antarctica. These glaciers are also called as alpine type of glaciers. The name comes from the Alps of the Central Europe, where such glaciers are distributed very well. Mountain or valley glaciers. The mountain glaciers are relatively small glaciers. On the planet Earth, the largest mountain glaciers are found in Arctic Canada, Alaska, the Andes in South America, the Himalayas in Asia, and on the Antarctica. Alpine glaciers have several subtypes. The notable ones are Circ Glaciers, Valley Glaciers, Hanging Glaciers, Piedmont Glaciers, Tidewater or Tidal Glaciers, Icebergs. Every type of glacier is characterized by its own altitude, shape, size, and dimension. These glaciers have their own mass balance with typical input and out sequences during every seasons. Cirque Glaciers. Cirque Glaciers are the smallest of the mountain glaciers. They occupy the bowl-shaped depressions existing in mountain tops. Cirque is the name for the bowl-shaped depressions present in the mountains. Typically, they are found high on mountain sides and tend to be wide rather than long. Cirques are situated on high mountain sides near the firn line. They are typically surrounded by steep cliffs on three sides. The highest cliff often is called as a head wall. Chandra Tal is located in the Himalayas. It is popularly known as the Lake of the Moon. It is situated at an altitude of about 4,300 meters. The mountains of Scree overlook the lake on one side, and a magnificent cirque presents a view on the other side. Larger and larger, they may spread into the valleys and flow down the valleys as valley glaciers. The moving parts of the valley glaciers are controlled by the prevailing topographic conditions. Valley glaciers. The valley glaciers occupy the valley portions of the very high altitude mountains. Valley glaciers range in length from 100 meters to more than 100 kilometers. Near the equator, valley glaciers can be very short, maybe only 2 or 3 kilometers in length, but in North America and Europe, the valley glaciers are much longer and larger. The Lambert Glacier in Antarctica is the longest one in the world. It has a length of 700 kilometers. The Alesh Glacier in Switzerland is about 23 kilometers long. Austria's longest glacier is the Pastry, which is about 8 kilometers long. The Valley of Silence, the Western Coombe, is a bowl-shaped valley or cirque located at the foot of the Lhotse face of the Mount Everest. If a valley glacier extends down to the sea level, then it may carve a narrow valley deep inside the coastline. These are called as fjord glaciers. Hanging glaciers. Hanging glaciers originate on high mountain ranges. They develop on the wall of a glacial valley and descends only part of the way to the surface of the main glacier. A hanging glacier resembles like a tributary glacier that is incised into the upper part of a U-shaped main glacier valley, higher than the floor of the main valley. Hanging valley streams often enter into the main valley as waterfalls. These glaciers also form similar distributions with ice. The hanging glaciers appear like ice aprons. The hanging glaciers are common in the Alps, where they often cause avalanches due to the steep slopes in which they occupy. Piedmont Glaciers. Piedmont Glaciers are formed when a valley glacier extends down through a valley and then covers a gentle slope beyond the mountain range. Piedmont Glaciers occur when steep valley glaciers spill into relatively flat plains. At the end, they spread out into bulb-like lobes. The Malaspina Glacier in Alaska is one of the most famous examples of Piedmont Glacier. It is the largest Piedmont glacier in the world. Tidewater Glaciers. Tidewater glaciers are the glaciers which enter into the ocean and carve off to form icebergs. Tidewater glaciers are responsible for carving numerous small icebergs, which, although not as imposing as Antarctic icebergs, can still pose problems for shipping lanes. Tidewater glaciers are responsible for carving numerous small icebergs, which, although not as imposing as Antarctic icebergs, can still pose problems for shipping lanes. Carving is a process of breaking away of the block of ice from a glacier. If all of the valleys in a mountain range are fully covered by glaciers, then they are called as ice caps. Ice caps are very extensive fields of ice of very large magnitude and dimension. Icebergs. An iceberg is a large piece of ice that has broken off from a glacier or an ice shelf. It is a freely floating ice block in open water. It may subsequently become frozen into a large pack ice. The iceberg B-15 is one of the world's largest recorded icebergs. It is around 295 kilometers long and 37 kilometers wide. It has a surface area of 11,000 square kilometers. It was carved from the Ross Ice Shelf of Antarctica in March 2000. The largest iceberg on record was encountered first near Baffin Island in 1882. It was 13 kilometers long by 6 kilometers wide, had a freeboard, height above water of about 20 meters, and a mass in excess of 9 billion tons. Icebergs are classified on the basis of their shapes. The two basic types of iceberg forms are tabular and non-tabular. Tabular icebergs have steep sides and a flat top. The non-tabular icebergs have different shapes which include dome, pinnacle, wedge, blocks, and docks. Continental glaciers. The continental glaciers are the largest types of glaciers on Earth. The continental glaciers represent the great ice sheets of the globe. They normally obscure the topography over large sections of a continent which may be beyond 50,000 square kilometers. The subtypes of these glaciers are ice sheets, ice caps, ice shelves, ice fields. Ice sheets. Ice sheet is a mass of land ice of continental size. It is thick enough to cover the underlying bedrock topography. Its shape is mainly determined by the dynamics of its outward flow. These ice sheets are vast masses of glacial ice and snow expanding over 50,000 square kilometers. The continental ice sheets have an estimated volume of about 24 million cubic kilometers of ice. If these masses are melted, they may produce enough water to raise the sea level up to 66 meters. The glaciers that cover Antarctica and Greenland are the two major modern continental ice sheets in the world. These two ice sheets comprise of about 95% of all glacial ice currently on Earth. Antarctica alone has 92% of all the glacial ice on the planet. The ice sheet on the Antarctica is more than 4,200 meters thick in some areas, covering nearly all of the land features except the Transantarctic Mountains, which protrude above the ice. The ice sheet acts like a conveyor belt, taking ice from the atmosphere and delivering it back to the sea. Although the surface of the ice sheet is cold, the base of the ice sheet is generally warmer. In places it melts, and the meltwater lubricates the ice sheet so that it flows more rapidly. This process produces fast-flowing channels in the ice sheets. They are called as ice streams. Ice caps. The ice caps are dome-shaped ice mass with radial flow, usually covering the underlying topography. These are miniature ice sheets covering less than 50,000 square kilometers. When a glacier lies on a high mountain plateau and moves out in all directions, it is called an ice cap. The difference between ice sheet and an ice cap is one of the scale. The ice sheets are larger in size. The glacier that covers the Iceland is an ice cap. A small ice cap on the northeast side of James Ross Island in the Antarctic Peninsula region forms a white dome-shaped feature, capping the dark grey volcanic rocks below. Ice shelves. Ice shelf is a thick, floating slab of freshwater ice extending from the coast, nourished by the land ice. In thickness, they range from a few hundred meters to over 1,000 meters. Nearly all ice shelves are located in Antarctica. They may also contain massive icebergs. Along the coasts of Greenland, Canada, and Antarctica, there are numerous ice shelves extending over the sea while still attached to continental ice. Being afloat, ice shelves experience no friction under them, so they tend to flow even more rapidly than ice streams, up to 3 kilometers per year. Ice fields. An ice field is an extensive area of land ice covering a mountainous region. Its surface is almost flat and can be distinguished from an ice cap because it does not achieve the characteristic dome-like shape. The flow in an ice field is strongly influenced by the underlying topography. Distribution of glaciers. Glaciers Ice caps and continental ice sheets cover about 10% of the Earth's surface at present. Glaciarized areas cover more than 15 million square kilometers. Glaciers are the largest reservoirs of fresh water on Earth. They store about 75% of the world's freshwater resources. The two major zones are the Greenland and Antarctica. The remaining ice covers various mountains and fills some alpine valleys. The ice occupies about 2.15% of the world's total water masses, 29,492 cubic kilometers, next to the oceans. The world's glacier inventory, WGI, enlists about 107,000 glaciers that are existing in about 28 countries. Some glaciers are as small as football fields. Some glaciers are more than a few hundred kilometers long and several kilometers wide. Due to their unique ability, glaciers accomplish great destructive and constructive capabilities along their flow paths. Here, table number 1 shows the approximate distribution of major glaciers on a global scale in square kilometers. Antarctica has 11.965 million square kilometers. Greenland has 1.784 million square kilometers. Canada has 0.2 million square kilometers. Central Asia has 0.109 million square kilometers. Russia has 82,000 square kilometers. United States, including Alaska, has 75,000 square kilometers. China and Tibet have 33,000 square kilometers. South America has 25,000 square kilometers. Iceland has 11,260 square kilometers. Scandinavia has 2,909 square kilometers. Alps has 2,900 square kilometers. New Zealand has 1,159 square kilometers. Mexico has 11 square kilometers. Indonesia has 7.5 square kilometers. Africa has 10 square kilometers. Total glacier coverage. Total glacier coverage in the world is nearly 15 million square kilometers. Glaciers occur on every continent and approximately in 47 countries. Most of these glacial masses are affected by long-term climatic changes. The precipitation, mean temperature, and cloud cover, and the glacial mass changes are considered to be among the most sensitive indicators of climate change. Melting of glaciers will have a major impact on the sea level. Formation of glaciers. Glaciers are formed from the accumulation of snow and conversion of it into ice. The process of glacier formation, growth and movement is called glaciation. Glaciation has occurred several times during the Earth's geological history. Due to continuous accumulation of snow, they transform into ice. Each year, new layers of snow are created, buried and compressed over the previous layers. This compression forces the snow to recrystallize and form grains of similar size and shape, like sugar crystals. Gradually, these grains grow larger and larger. The air pockets lying between these grains get smaller, causing the snow to slowly compact and increase in its density. After two subsequent winters, the snow turns into a state called as firn. This is an intermediate state between snow and glacier ice. At this point, the mass is about half as dense as water. Over a period of time, these larger ice crystals become so compressed and cannot leave any air pockets. These crystals may also be very big in dimension. For most of the global glaciers, This process takes over 100 years. But the Pleistocene glaciations is the most recent and extensive one, showing clear records to study the world. Development of glaciers. The formation of glacial ice has three stages as snow accumulation, firn formation, ice formation. The conversion of snow into ice involves three major steps as accumulation of snow, formation of ice granules, formation of glacial ice. The accumulation of snow is the first stage. Snowfields grow in areas above the snow line where more snow accumulates in the winter and then melts during the summer. The formation of ice granules is the second stage. As the snow accumulates and gets thicker, sublimation happens, transformation of solid to gas, and pressure changes it into firn, ice granules. The formation of glacial ice is the third stage. With further accumulation, compaction, and pressure melting, released water that refreezes to cement ice granules together causes firn to be transformed into glacial ice, mass of interlocking crystals. Glaciers begin to form when snow remains in the same area throughout the year. Factors of glaciation. The factors that are responsible for the formation of glaciers are precipitation, temperature, latitude, altitude, topographic relief, and aspect. Precipitation, the primary source. Precipitation is a major factor for global glaciation. The amount of precipitation, whether in the form of snowfall, freezing rain, or snow avalanches, is important for the survival of the glaciers. A ready supply of snow is needed during precipitation for glaciers to form. Many locations on the planet Earth receive huge amounts of snow every year, but have not formed any glaciers. In some other places, with little snowfalls, one can see massive glaciers. If a glacier is to be formed and survived, some amount of snow must be saved year after year. Temperature and latitude. The second factor is the temperature. The sun's solar radiation has the most significant influence on oblation. For glaciers to survive, the mean summer temperature is of the greatest importance. The fallen snow needs to stick around, and chances get improved only when the summer temperature is very low. The third important factor is the latitude. High latitudes receive less annual solar radiation and experience prolonged winters at sub-zero temperatures. That is why glaciers prefer polar regions. It is also interesting to note that in our present plate tectonic configuration, the South Pole landmass is ideal for glaciers to long last. Topography and slope. Topography has a powerful influence over glaciation. Altitude is yet another factor for glaciers. Glaciers are found at sea level at the South Pole, but in the mid and low latitudes, glaciers are related to very highlands. Alpine regions are the prime zone for glacier formation. Aspect is one more important parameter for glaciation. It refers to the orientation of the ground surface with respect to incoming solar radiation. The proper slope aspect lowers the configuration of snowline. Steep north-facing slopes receive the least direct radiation in the northern hemisphere. The slopes facing east of north are the coolest. Glacial accumulation. Glaciers expand in response to the accumulation of snow and contraction from wastage, loss of ice. Glaciers can be divided into two distinct zones as the zone of accumulation and the zone of wastage. The zone of accumulation is the zone above the snow line, where snow accumulates faster than it is removed by melting and evaporation. The zone of wastage, ablation, is the zone below the snow line or firn limit where wastage exceeds accumulation. Wastage processes include three mechanisms as melting, sublimation, and calving. Melting is caused by friction at sides and bottom of ice mass and by warming during the summer months. Sublimation is the conversion of ice directly to water vapor without an intermediate liquid phase. Calving is the breaking off of blocks of ice at ends of glaciers that reach the ocean, where icebergs are produced. Movement of glaciers. Glacial motion. Glacier is a natural moving body of crystalline ice of great dimension. It is brittle in nature. When struck sharply, it will create crevices and fractures. Glaciers move by internal deformation and basal sliding. When ice reaches a thickness of about 40 meters, it begins to flow and becomes a glacier. Ice masses flow not only over flat terrain, but also on the hill slopes. Only after an ice mass has attained a particular size, thickness, and configuration, it gets enough stress to cause it to flow as a solid or to slip over its base. Glacial movement is due to two mechanisms. One is plastic flow and the other one is basal sliding. Plastic flow. Plastic flow of glacial ice comes due to the pressure on ice deeper than its depth. In plastic flow, the shape is changed. Much amount of mass ends up at the downhill areas. Basal sliding. In basal sliding, the glacier slides over the terrain on which it sits, lubricated by the presence of liquid water. As the pressure increases toward the base of the glacier, the melting point of water decreases and the ice melts. Friction between ice and rock and geothermal heat from the Earth's interior also contribute to this melting. All these act together on basal sliding. Basal slips are dominant in temperate or warm-based glaciers. In basal slips, the base of the glacier moves slowly because of friction. Basal slip is the most rapid movement expected in the warmer months and can also produce surges. Glacial surge is another major aspect in glaciers. Glacial surges are short-lived events where a glacier can advance substantially, moving at velocities up to 100 times faster than the normal movement. A glacier surge may be several meters per day for weeks or even months. Surging is an unpredictable event in glaciated terrains. Factors controlling ice flow. The rate of glacial movement vary depending upon various factors. Most of the glaciers flow directly under the influence of gravity. The ice flows due to the pressure created by its own weight. In general, the valley glaciers move faster than the continental glaciers. It varies from few meters to hundreds of meters per day. The surface of the glacier moves faster than the sides and the center. In valley glaciers, the rates of movement vary from centimeters per day to tens of meters per day. The steeper the slope, the faster the rate of movement. Larger ice masses move faster than smaller ice masses. Rate of ice flow. In a valley glacier, the ice moves fastest at the upper center part of zone of plastic flow. In continental glaciers, the average rate of movement is a few centimeters per day or a few meters per day. Flow rates are very fast in the zone of accumulation and get reduced below the firn line towards the margins. The thicker ice sheets have higher flow rates than the thinner ones. These glaciers show little basal slip and may be frozen at the underlying surface. The rate of ice flow may be extremely slow and the movement is continuous over the years. The smaller ones move from 90 to 150 meters per year. The larger ones may move to about 180 meters per year. A glacier in Himalayas was found to be advanced for 11 kilometers in 3 months. Glacial processes. Glaciers respond quickly to changes in climate because they generally lose more mass on an annual basis compared to their total mass. There are two mechanisms in the life of glaciers. One is glacial advance and the other one is glacial retreat. Glacial advance is spreading glaciations. Glacial retreat is loss of glacial ice and their coverage due to evaporation and melting. Glaciers advance and retreat regularly. Glacial advance. Glacial advance is a positive outlook. As precipitation adds more mass to a glacier than melting and sublimation remove, the total volume of the glacier increases. As a result, the glacier grows, extending farther down the valley than it did previously. This is called as glacial advance. There must have been at least 17 major glacial advances, glaciations, in the last 1.6 million years alone. Over the last century, mountain glaciers worldwide have been decreasing in length and volume. Glacial retreat. Glacial retreat results in the loss of the low elevation region of the glacier. Since higher elevations are cooler, the disappearance of the lowest portion of the glacier reduces overall ablation, thereby increasing the mass balance and potentially re-establishing the equilibrium. The key symptom of a glacier in disequilibrium is thinning along the entire length of the glacier. Glacial retreat is tied up with two main climatic changes. These are increased temperatures and changes in precipitation and atmospheric moisture. Other factors, such as solar radiation, also play a role in glacial retreat. Himalayan glaciers have been in a state of general retreat since 1850, and recent publications confirm that, for many, the rate of retreat is accelerating. The normal rate of retreat of some glaciers in the Himalayan ranges are found to be varying from 8 meters per year to 23 meters per year. These continued retreats have a lot of impacts on the other resources. Many glaciers are being lost due to melting. These are raising concerns about the future local water resources in many glaciarized areas of the world. Features of glaciers. There are several features and processes associated with glaciers. The notable ones are bergstrand, foliation, ice falls, ice streams, ogives. Bergstrand. A bergstrand is a deep and often wide gap or crevice or series of closely spaced crevices in ice or fern at or near the head of a valley glacier. A bergstrand separates the moving ice and snow from the relatively immobile ice and snow adhering to the head wall of a valley. Foliation. One of the striking features of many glaciers is the banding in ice that occurs in the ablation zone. Foliation consists of alternating layers of white bubbly ice and bluish ice. Layers vary from several millimeters to several meters in width. Ice falls. Ice falls occur on the parts of a glacier that flow over convex bedrock surfaces and are thereby very steep. Ice falls are highly crevassed. Ogives. Ogives are broad-banded surface patterns that generally curve down glacier as a result of faster ice movement toward the center of a glacier. Ogives are common below ice falls. Geological action of glaciers. Geological work of glaciers. Glaciers also participate in the exogenous geological processes on the surface of the Earth. Glaciers have the power and force to erode, transport, and deposit the surface materials similar to wind or rivers. Hence, they are also called as geological agents. Glacial erosion happens in two processes, as plucking and abrasion. Ice is a mineral having a hardness of 1.5 on Mohs scale of hardness. It is by nature unable to scratch the hard rocks and minerals. It needs the supporting material for attaining the erosive power. Hence, the process of abrasion comes in. Bulldozing is yet another mechanism of erosion in which the glacier pushes the loose material along its path. Plucking. Plucking, which is also called as quarrying, is similar to the frost wedging. Plucking process allows glaciers to erode bedrock surfaces via a three-stage progression. In the first stage, meltwater at the base of the glacier seeps into cracks in the bedrock. Once collected in these fractures, the water freezes and expands, further fracturing the rocks and making the bedrock debris available to the glacier for erosion. This debris is then removed either by freezing to the bottom of the glacier or by being dislodged by rocks projecting from the bottom of the ice. Abrasion. Abrasion is the second major erosional process. In this process, the rock fragments carried by ice function like sandpaper that scours the surface over which the ice moves. This process produces rock flow, very fine particles of pulverized rock, striations, long grooves and scratches cut into bedrock, and glacial polish, a very smooth surface produced by fine abrasion of bedrock by rock flow. The scratches, striations, grooves and furrows are determined by size of the sediments. The direction of striation is a good indicator to show the flow direction of glaciers. Factors of glacial erosion. The major factors that influence glacial erosion are temperature, amount and nature of debris present in basal ice, presence of water, thickness of the ice, flow velocity, resistance of bed materials, structure of bed materials. Glacial transport. Glaciers transport the sediments along their flow paths. The rock fragments transported by the glaciers are called as their loads. Most of the sediments are carried in suspension. Large blocks and small blocks are transported together, unlike rivers, without sorting and separation. Due to this, the resultant glacial deposits are mostly unsorted. It is also very important to note that much of the materials are unweathered. Glaciers transport their sediments along three vertical zones as, at their bases, subglacial transport, at their surfaces, supraglacial transport, and within their ice bodies, englacial transport. Subglacial transport. In subglacial transport, the particles that are not encased in a glacier's ice may be moved as individual pieces across the bed by means of traction, slipping, and rolling under propulsion from the overriding glacier. Supraglacial transport. In supraglacial transport, the glaciers may acquire debris as material falling onto the ice surface from rock walls or other ice-free areas. The supraglacial debris is carried on the surfaces of glaciers. Debris can continue to be carried on a glacier surface within the ablation zone, but above the equilibrium line. Later, it will become progressively buried because of the accumulation of ice from above. Englacial transport. In englacial transport, once the debris are buried, it becomes englacial debris and can travel as such to a glacier's snout. Alternatively, it may emerge at the surface in the ablation zone through melting of overlying ice, or it can move down to the glacier bed and be trapped by existing subglacial debris. Glacial deposition. Glacial deposits are known as drifts. They are subdivided into two major types as tilts and stratified drifts. Both stratified or unstratified glacial drifts occur in nature. The stratified drifts include the following features: glacial outwash plains, kettles, kames, eskers, wharves. Outwash plains. When a glacier melts, it produces water-laid deposits. These deposits are laid near the foot of the glacier. They are called as glacial outwash. These water-laid deposits are distinguished from till in that they are stratified deposits of glacial drift. Glaciers that are stagnant or that are retreating due to rapid melting at the terminus deposit large amounts of stratified drift. In mountainous areas, these deposits are called valley trains. In flat terrain, they are called as outwash plains. Erosional features. Glacial landforms. Fjords, glaciated valleys, and horns are all the erosional landforms of glaciers. The popular glacial landforms are: Arete is a sharp ridge of erosion-resistant rock. It is formed when two Circ glaciers converge but do not meet and allow a spine of rock to remain between them. Fjord is a long, narrow, deep arm of the sea filling a glaciated coastal mountain valley. Horn is a high, sharp, steep-sided pyramidal peak sculpted by cirques working headward from several sides. Truncated spurs refer to the toe of a mountain or hill that has been eroded away by a glacier. Whalebacks are smooth, glacially sculptured bedrock knob of modest size resembling the back of a whale. Cirques are deep horseshoe-shaped basins formed as a result of glacial erosion. These are the headwaters of a glacier. As the glacier retreats and eventually completely disappears, a lake will often remain in the cirque. Such lakes are known as tarn lakes. Roche mountainy are called as rock drumlins. These are asymmetric knolls or hills made of bedrock. Glaciated valleys. U-shaped valleys. Most valleys formed by stream erosion will have normally a V-shaped profile, but the valleys of the glaciers are U-shaped valleys. This is due to the result of the mechanics of glacial flow. The ice at the top and bottom of the glacier tend to flow slower than the ice in the middle. As a result, the faster moving ice in the middle has a greater ability to erode the valley walls than the ice at the top or the bottom. This removes the valley wall material as we approach the apex of the V and transforms it into a U. Glacial U-shaped valleys are carved out by the scouring action of a glacier. Braided stream. Braided streams are common in glaciated landscapes. The network of intertwining channels of braided streams resemble the strands of a complex braid. Sandbars separate the branching and reuniting channels. Features of deposition. The following are the features of deposition normally made by glaciers. Gittija is a dark, pulpy freshwater mud characterized by abundant organic matter. It is an anaerobic sediment laid down under varying aerobic to anaerobic conditions. Kame is a broad term describing a mound of sediment formed by the initial deposition of material within a cavity in the ice, followed by slumping of this material as the supporting ice walls melt away. Esker is a long, low ridge of sand and gravel that was deposited by meltwater in a subglacial ice tunnel or an ice-walled channel. They are the classic linear feature, although they may be sinuous and or discontinuous in reality, which generally show a close correspondence with the most recent direction of ice movement. An esker is a sinuous ridge of stratified fluvial sediments deposited underneath a glacier in meltwater channels. These channels are initially eroded both into the underlying bedrock, but as the channel fills, it begins to erode into the overlying ice while continuing to deposit sediments. When the ice retreats, these channel deposits are left behind as topographic ice. Eskers vary greatly in size and extent but can be 100 feet high and 100 miles long. Glacial lakes and basins. Glacial basins. One thing that glaciers do well, given favorable conditions such as thick, fast-moving, warm ice and well-jointed bedrock, is excavation. Localized excavation can create closed bedrock basins, many of which ultimately harbor lakes. Examples of these lakes are tarns and paternoster lakes. Tarns are single lakes. Paternoster lakes are a string of lakes connected by a trunk stream that resemble beads on a rosary chain, hence the name Our Father Lakes. Types of glacial moraines. Till. Till is a term used to denote the unsorted, unstratified drifts deposited directly by the glacier. Till is an ill-sorted mixture of fine and coarse rock debris. Chunks of till may show signs of frequent breakage that they received during transport or partial smoothing by abrasion. Till consists of sand, silt, pebbles, cobbles, boulders, and other debris. The till deposits include three major depositional features. They are glacial moraines, drumlins, and erratics. Glacial moraines. A moraine is an elongated ridge of unconsolidated drift deposited along the margins of a glacier. Moraines can be extremely short-lived features. They can have ice cores and collapse into insignificant forms when the core melts. They can be destroyed by meltwater, advances of subsequent glaciers, or collapse after the loss of support from glaciers that retreat. These detrital deposits include sediments ranging from fine particles to large boulders. Types of moraines. The moraines are classified into various types depending upon their location. The notable types are: the ground moraines are deposits accumulating along the bottom of a glacier. These are parallel to the direction of ice flow, containing formless sheet of till. An end moraine is the general term used to describe a moraine deposited at the toe of the glacier during times of glacial stability. They are transverse ridges or groups of ridges which delimit the former ice front positions. A terminal moraine is an end moraine that marks the greatest advance of the glacier before its retreat. A recessional moraine is an end moraine deposited during periods of stability while the glacier is retreating. A lateral moraine is deposited along the margins of a glacier, often found on the walls of U-shaped valleys. Lateral moraines run parallel to the direction of ice flow and lie at the sides of a glacier. The medial moraines are located in the middle of the glacier, parallel to the sides. They are formed by the merging of two lateral moraines when two adjacent glaciers merge. Medial moraines have a slim chance of survival after a glacier has departed. Drumlins. Drumlins are notable landforms created by glaciers. Drumlins are low, elongated, streamlined hills consisting of glacial sediments or carved bedrocks. It has a blunt nose pointing in the direction from which the ice approached, and a gentler slope tapering in the other direction. The striations and orientation of the drumlins indicate the direction of ice flow. Hundreds to thousands of drumlins are normally found in one place. Erratics. During the time of glacial recession, large boulders carried by the glaciers are left as stranded objects. These out-of-place rocks are called as erratics. Some erratics show glacial striations and polish. Ice ages. Concept of ice age. Glaciers preserve the physical conditions of atmosphere from thousands of years ago in these tiny air bubbles. Through these only, scientists came to know that there have been several ice ages. Past eras can be reconstructed, showing how and why climate changed and how it might change in the future. An ice age is a period of long-term reduction in the temperature of Earth's climate, resulting in an expansion of the continental ice sheets, polar ice sheets, and mountain glaciers. Glacial ice can range in age from several hundred to several hundreds of thousands years. They are valuable indicators for global climate research. To decipher the long-term climate records, ice cores are drilled and extracted from the glaciers. These cores are continuous records of information regarding the past climate. Scientists analyze various components of cores, particularly trapped air bubbles, which reveal past atmospheric composition, temperature variations, and types of vegetation. The 5 known ice ages. There have been 5 known ice ages in the Earth's history, with the Earth experiencing the Quaternary Ice Age during the present time. Within ice ages, there existed periods of more severe glacial conditions that are referred to as glacial periods and interglacial periods. The earliest hypothesized ice age is believed to have occurred around 2.7 to 2.3 billion or 10 to the power of 9 years ago during the early Proterozoic age. There were extensive polar ice caps at intervals from 350 to 260 million years ago during the Carboniferous and early Permian periods associated with the Karoo Ice Age. Major glacial periods. The 500 million year record shows the current and previous major glacial periods. Glacial budget. Glacial budget is computed based on the concept of mass balance. The term mass balance refers to the difference between annual snow and ice accumulation and snow and ice ablation. It can be represented as an average thickness added to or lost from a glacier for a given year. It is the most sensitive annual glacier climate indicator. Mass balance is evaluated by measuring the addition and loss of snow and ice mass at points on a glacier surface and extrapolating the point data to the whole glacier surface. Ablation is measured by emplacing stakes in the glacier. As the glacier surface melts, that amount of the stake emerging from the glacier is measured. The total melt at each stake by the end of the melt season is the net ablation. Most of the stakes must be replaced during the summer. The glacial accumulation is measured by either probing or based on ice and snow stratigraphy depicted in the crevices. Analyzing crevice layering is similar to reading the widths of tree rings. Glaciers and global climate. Glaciers are sensitive to climate changes of various magnitudes and different time scales. Their widespread geographic distribution makes them suitable for establishing data and for evaluating the nature of global climate fluctuations. Any variations in climate cause glaciers to advance and retreat. Glaciers can serve as excellent indicators of climate change. Glaciers are very sensitive to the temperature fluctuations in the atmosphere. They are subjected to the variations of any climate change. Most of these glacial masses are affected by long-term climate changes, example, precipitation, mean temperature, and cloud cover. Glacial mass changes are considered among the most sensitive indicators of climate change. Melting of glaciers will have a major impact on the sea level. There are many direct and indirect effects of glaciations. Indirect effects of glaciation. The indirect effects of glaciation are causing important climatic changes, changed sea levels. Glaciers stored more than 70 million cubic kilometers of water, lowering the sea level to 130 meters. If all glacial ice were to melt, the sea level would rise by about 70 meters, flooding almost all the densely populated coastal zones. Forced plants and animals to migrate, diverted stream drainage patterns and caused downcutting by streams. Weight of ice depressed continental crust. Importance of glaciers. The benefits and hazards of glaciers demand with reasons for monitoring the glaciers. Monitoring of glaciers is important for assessing and predicting the impacts of glacial retreat on water resources in mountainous areas. There are a lot of commercial value attached to the existence of glacier ice. Electric power generation, tourism, and sea level rise are the major aspects. Glaciers are good habitat for several faunal species. Protecting the rare species that live in glaciers is an important aspect to be kept in mind. Glaciers provide many benefits to us as humans as well as to other species. The natural hazards created by glaciers are another important reason for monitoring them. Glaciers pose dangers to ocean transportation and shipping, as well as offshore oil installations. Icebergs, surging, outburst floods, ice avalanches, and sea level rise are the major issues of concern about the glaciers.